What if you could use blockchain to oust a tyrannical boss at your company? Wouldn't that be cool? This video explains how that kind of thing might be possible, especially since blockchain will help us solve public goods problems. The tyrannical boss is actually a classic economics public good problem, so it's worth learning how these things work on blockchain, if anything just for the fun game theory. So how would this work? Well, you've got this tyrannical boss at your workplace, and he bullies people, and he takes credit for other people's work, and he starts false rumors. He's just a jerk. But he's in a position of power in your workplace. Or maybe it's a passive-aggressive tyrant like Professor Umbridge from the 5th Harry Potter book. Either way, one day a coworker comes to you with a petition to get this tyrant removed from their position of power. And the petition outlines things about this person that everybody knows are true, everybody talks about them around the water cooler, but the question is, do you sign that petition? Here's the thing, you know what happens to people who expose a tyrant, right? They get their heads chopped off. That's just how this world works. The tyrant has maybe dealt with similar uprisings in the past, and they have a plan in place. He's probably got a really good relationship with his boss, so that the higher-ups all take his side, and he's highly skilled at vengeance. What's more, everybody knows this, so if you sign that petition, you're gonna be the only one signing it. Everyone else is gonna be super cowardly and will say, oh, I don't agree with anything on that petition, even though that's not true, just so they can save their butts with the company. And then you'll be all alone on that guillotine. So no thanks. But you might be willing to sign that petition if 80% of the company also signs it. In which case you'd be one among many, and you'd be really hard to single out as one person to take vengeance against. So how can blockchain help? Well, blockchain is a public immutable ledger, and you can write up smart contracts onto that blockchain that will execute automatically when the conditions in your contract are met. So imagine if everybody in your company wrote up a little smart contract and put it onto a blockchain, and everybody's smart contract said the same thing, which is, if 80% of people at my company sign their name to this petition against the tyrant, then sign my name. If less than 80% of people sign it, then don't sign my name. And obviously you don't want people to see that you've written this contract, you just want it to execute automatically if 80% of your company also signs. And there are a number of different ways of handling that privacy, but one way would be to encrypt your smart contract. And that basically means you can't read the smart contract unless you have the key. And the key acts like a magic magnifying glass, which will make your contract readable to someone. And the only one who gets the key is a robot who has a strict rule written onto his brain to execute your contracts exactly like you say they should be executed, and to never tell anybody about your smart contracts. And so you're actually safe from exposure if this robot has the key. And then whenever you're at the water cooler at your company and people start to complain about this petty tyrant, you tell them about the blockchain and you encourage them to write up their own little smart contract and to give the keys to their smart contract to the same trustworthy robot. This way, the robot can see if 80% of the people at your company are willing to sign if everybody else signs. And of course, each person can write up their own percentage when they write up this contract. So maybe you're 80% cowardly, 20% brave, but maybe a coworker is actually much more cowardly than you and will only sign if 95% of people in the company sign. And maybe you have a coworker who's much more brave than you and they're willing to sign if only 20% of people sign this anti-tyrant petition. So it's kind of cool how this system actually quantifies your level of bravery or cowardice. So how does this relate to public goods? And I'll do a more formal definition of public goods in another video, and I'll link that below. For now, I'm just going to write up a game theory payoff matrix for this particular public good problem. This matrix imperfectly approximates the dilemma. Let's pretend the company has only 2 employees and a tyrannical boss. The cost of signing a petition is the risk of retribution from the tyrannical boss. The benefit of signing this petition is that the company may be willing to look into the boss's behavior and to put measures in place to hold this tyrant accountable. If both of you sign it, then there may be some passive-aggressive behavior toward both of you from the tyrannical boss. But that's going to be outweighed by the benefit of the increased accountability toward the boss from the higher-ups in the company. So you both get a payoff of 3 if you both sign. But the best situation would be for your coworker to write and sign the petition and for you to refrain from signing it. If that happens, there will be some investigation into the boss's bad behavior, but you won't be on the receiving end of any of the passive-aggressive gestures from your boss. You get a benefit of 5 in that case, which is more than you would have gotten if you would have signed alongside your coworker. But that situation is horrible for the coworker who signed the contract. The coworker in this case is going to receive a double whammy of passive-aggressive behavior from the boss, and the higher-ups who are holding that boss accountable might question the validity of the petition since only one person signed it. So the coworker gets a payoff of -2 if they sign and you don't. And of course the reverse is true if you sign the contract and they don't. If neither of you sign, then things go along as they have been, so the payoff matrix will show a payoff of 0 for both of you. You may notice that this is a prisoner's dilemma. Specifically, you have a dominant strategy, which is not to sign. If the other player signs, you will wish you had not signed. If the other player doesn't sign, you will wish you had not signed. And that's a dominant strategy. But both players are better off when they play their non-dominant strategy, or dominated strategy, than when they play their dominant strategy. That's a prisoner's dilemma, and the Nash equilibrium in this case is for both players to not sign the petition. And you basically have a similar situation with public goods. So let's go over that. Now I'm going to do something that isn't really allowed with payoff matrices just to make this more obvious. Instead of a company with only 2 employees and a tyrannical boss, we'll give this company 1,000 employees. And instead of this other player being player 2, we'll let this other player be everybody else. Totally not allowed. And it's not allowed because there's no such thing as a player that's everybody else. Each of these people is making their own decision independently. So this doesn't 100% make sense, but stick with me. Doing it this way will give you the gist of what's going on without going into the hairy optimization problem. You have the same situation as before, right? If everybody at your company signs this petition, you will wish you hadn't signed, because then you'd avoid this passive-aggressive behavior from your boss, but you'd still get the benefits of that petition that everybody else signed. And if nobody signs the petition, your best strategy is to not sign the petition because you don't want your head chopped off. So not signing is a dominant strategy, but everybody would be better off if everybody signed the petition than if nobody signed the petition, even though the Nash equilibrium is for nobody to sign. And it's a weird situation because if there are 1,000 employees at the company, you signing that petition doesn't actually increase the odds that that petition will be taken seriously. Going from 500 to 501 signatures doesn't really matter. Your signature is a drop in the bucket, and that's an economics term related to public goods. So you have the free rider problem, and this is also a public goods term. Your dominant strategy is to be a free rider and to not sign, and to just hope that everybody else collectively will do what's right, which they won't. However, our clever little smart contract on our blockchain actually changed the game theory involved. We added this third option besides signing or not signing. You can write up one of these little contracts and put it on a blockchain and give the keys to that contract to a trustworthy robot. Now, there are 2 Nash equilibriums here, but one of these is a better Nash equilibrium for everyone. And if you aren't familiar with how I just solved that, I'll put a link below to a video explaining. So this smart contract actually solved this public goods problem and prisoner's dilemma. That feels pretty good. This setup is actually pretty similar to the way Kickstarter solves a public goods problem, and I'll define a public good more clearly and explain the Kickstarter version in another video. And it's worth talking about this stuff because I think these kinds of problems are the kind of problem that blockchain will really help the world solve. So, how does this relate to blockchain? And first I want to ask the question, could we have some of these conditional contracts without a blockchain? And the answer is probably yes Maybe. But blockchain makes the situation safer than it otherwise would be. What do you need to make this work? Well, first you need the ability to write up one of these conditional contracts. Second, you need someone trustworthy to look through everybody's contracts to see if there's a match or an equilibrium. So let's imagine a phone app. It would have a screen that would look like this, where you could click Start a Petition. And then you type up your petition and you put in everybody's emails in your company who might agree with you about the tyrannical boss. And then they will receive an email with a link. And if they sign in, they can fill in the blank. I will sign the petition if 30 other people in my company also sign. Any startup could create an app like that right now. The problem is trust. If you received an email like that, would you sign? Who is running the company? How are they making money? If you signed this contract, would they ever turn you over to your tyrannical boss? How might they use your data to profit them? And would they use it against you? And even if you know and trust the people who are running this app, the problem is that they can change the rules about how that app works at any time. So they may keep your petition signatures private for now, but that could change at the whim of the company's CEO. That is the scary part. And that's what blockchain aims to displace with a more transparent system. So here's one way this app might work if it were on a blockchain. The blockchain app might look similar or identical to the one I just described, except that the CEO is the blockchain robot that I've been talking about so much in this series. And the robot's brain is public and immutable. So anyone can go in and see the rules about how that robot's going to handle smart contracts on the app. So you can go in and read all of the fine print on the robot's brain and see a computer-coded statement that guarantees nobody other than the robot will ever read the smart contract you write up. There is no group of C-suite people who can change the rules on the robot's brain behind closed doors. The transparency, immutability, and auditability of this robot's brain makes you trust the robot in a way that you would not trust the CEO of a startup. And there you have it. Blockchain helped us solve this public goods problem that would have been much more difficult to solve without our hero robot with the blockchain brain.